Hello, everybody. Welcome to Automating Success. I'm your host, Joe Langton. Today I'm here with Al Youngwerth, and Al is going to be a very interesting guest, as always, that I bring on to Automating Success. But Al, why don't you go ahead and tell us a little bit about yourself?
Yeah, well, thank you. So Al Youngwerth, I've been involved in automation for a bit over 10 years now, maybe 11 years. My background is I started in computer science out of college, worked in high tech for about 10, 15 years. And then in the early 2000s, I started a company making clutches for motorcycles. So shifted into manufacturing and CNC manufacturing. And about 2012, we went to IMTS, and one of our objectives there was try to figure out how we could bring automation to our factory. And what we learned was that automation really wasn't for high mix manufacturing at that time. And we were very much a high mix manufacturing shop, had gone through a huge lean transformation. And so we were looking for something that was high mix. And so ended up starting VersaBuilt because of our journey to bring high mix automation to our own factory.
And that was with Recluse Motorsports.
That's correct. Yep.
Correct.
Yeah.
Okay. So for people that don't understand, that are listening to the show and don't know, so what's high mix manufacturing?
Well, it means different things to different people. And I think if you look at it from an automation perspective, if you have a CNC machine that is going to run more than 1, 2, 3 part families in the useful life of that machine, then from an automation point of view, I'd say you're entering that high mix category. And the reason is that automation is typically designed around a particular part. For us, what high mix was batches of a median batch size of 15 pieces and doing part changeovers, 2, 3, 4 times a day per machine. So that's kind of the other end of the spectrum. And we wanted to be able to have automation equipment that could really work in that spectrum. Could still handle relatively high volume stuff, but it wasn't automation just completely engineered around a single part or part family, but could really compete with the very best changeover times in lean high mix production.
Okay, so you identified the problem you needed to solve in your space. So then, and now I kind of get behind where you're at with the motivation to even start the company, since you already had Recluse running. So then how did you solve that problem for needing automation in a space that it didn't exist? Like, how long did it take you to get there, and how did you do it?
Yeah. So, from the time that we first started looking for automation equipment until we had a solution that I think was really well suited to high mix, was probably 18 months. We worked at the local system integrator. We had kind of an idea of how to address a part family that encompassed, maybe at the time 25 different part numbers for us, but all the parts were round. All of them were, bigger diameter than they were thick, and used similar types of fixturing. And so we designed a system using a robot and off-the-shelf grippers that could handle any of those types of parts. And it took us about 6 months maybe to integrate, those 25, 30 part numbers. But when we went to bring in the next type of part number, which wasn't that much different, it just had a diameter to height ratio that was a lot closer. They weren't thin, they were thicker round parts. That whole design totally fell apart. And so we were, we didn't just have that part family. We had about 12 other part families we had to integrate. So we were standing around the robot and the CNC machine and kind of brainstorming ideas. And one of the guys said, "Hey, why can't the robot pick up the vice jaws to pick up the part and move it around?" instead of having the gripper pick up the part. And one of the other guys said, "Well, dummy, the vice jaws are bolted to the vise." And then I thought, I think we could solve that problem. So that little, light bulb of a moment turned into a new patented invention that we call multi-grip. It's also known as six-sided work holding, six-sided automation work holding, and basically it bypasses a traditional robot gripper and uses the vise or the vise jaws to pick up the parts and move them around. And especially for someone that's a machinist, they're not really good at robot programming, and they're not really good at designing gripper fingers or automation processes. So when the automation and introducing a part to the automation process is through familiar tools like CNC work holding, we greatly simplify the time and cost and education level required to add a new part to automation. And then by doing some other common tricks in high mix CNC work holding, we can make part changeovers really, really quick. And then there was kind of a surprising benefit that we didn't expect at the time, but we also solved one of the main problems that automation engineers face in CNC automation, at least CNC milling automation, and that is the Op1 to Op2 transfer. Now, typically that is done with a regrip step and a regrip station. That is, again, very part specific and requires custom programming. All those things are anti-high mix, right? They all add more time, require more robot types of skills. And our technology also solved that problem. So that was a big breakthrough for us. And that's really what, when I saw what we could do with that, that's when I decided to start VersaBuilt. And once we implemented that technology, we went from about 25 parts automated in 6 months to the next 6 months. After that, we had about 250 parts automated. And those machines are still running. I'm still in the same building. VersaBuilt and Recluse Motorsports share the same building. We have, I think the oldest system down there is now 11 years old, and it runs production every single day.
So there's a couple things that I want to unwrap from what you said. So the first thing is, I think it's so important how you brought up the fact that, when you're engineering or designing something in automation, you have to make it easily usable by the person that's not an automation expert, right? I feel like sometimes the failures in our automation space right now are really brilliant engineers making a piece of automation, but forgetting who actually is going to use it, right?
Yeah.
So it sounds like you really have a great solution for that for others using it. So now, are you going to market? You solved the problem for you, but now are you spreading out and selling this to other people that have the same problem?
Yeah, absolutely. Yeah. So VersaBuilt's been in business for about 10 years. We have hundreds of systems in the field. We started with an industrial robot-based product called the BBX 160. We sold that for about 5 years, and then we decided to exit the industrial robot market in favor of the collaborative robot market. And we licensed that product to a subsidiary of Gossiger called Automation Within Reach, and they continue to sell that product. It's been very successful. It's a great product. It's shelf-based product, very popular. But we were really trying to take the scaling of our business to the next step. And one of the problems that we found with the BBX 160 is that when we did an installation, it took us 5 days to do. We are not, most automation historically has been deployed by regional system integrators, where if there's a problem with the robot, someone's going to hop in a van, drive a half an hour and go solve the problem. And that's a lot more difficult to do with an industrial robot than a collaborative robot. And so we decided to shift to collaborative robots. About 2019 is when we made that shift. So now we sell collaborative robots or automation systems based on collaborative robots because they bring the ease of use to the next level. And not just in operation, I would say there's a lot of automation systems out there, whether they're industrial or based on collaborative robots, or if they're a standard automation system like we sell, or a custom automation system like is what has been historically done, custom for a particular part for high volume applications. Most of those systems are relatively easy to use for the operator. They're not always easy to use for the machinist. And from our perspective, that's really just as important, if not more important than it is for the operator to be easy to use, because the vast majority of manufacturing in the United States is high mix manufacturing. And if you have to hire an expensive robot engineer every time you want to add a new part to their system, you're not going to add very many new parts to that system, and it's going to have a very limited scope of value. A typical machine shop might have 20 machines, and maybe they have 1 or 2 machines that are dedicated to high volume, but the rest of those machines are high mix. So our products, our automation products, are really focused at the machinist to make it sure that they are enabled to add their own parts to the system, diagnose problems in that system, and make it work.
So, I want to step a little further into what made you want to automate your previous company in the first place, because, so many people, when I'm selling automation, and buyers or people who want it are always thinking cost, but I think things like safety and reliability and quality, it's like a specific amount of quality control. So can you tell me in your experience, what made, automation important for you, in what you were already doing?
So I think I went into it very naive. And I think that really helped us get where we ultimately ended up and make some real breakthroughs in technology, and what automation can be used for. When we first started inquiring about automation, we went to some of the big, CNC system integrators. I won't name names, but some of the top 5 kind of players, and said, "Hey, we've got 250 part numbers we want to automate, across 20 machines. What can you do for us?" And the typical response was a laugh, followed by, we can automate 1 part number at a time, or 1 part family at a time. That'll take about 9 months and cost about $250,000 per machine. And that didn't make any sense to me. That was not going to work for us. Certainly it would work in maybe a automotive production line that's, where 1 machine or a group of machines is making the same part over and over again for many years, but it wasn't going to work for us. And so that's what our driver was. We had to have high mix automation. And even back in 2012, I recognized back then how much CNC operator labor was a constraint to the growth of our business. We had, back then for us, our primary problem was that we were a business that was extremely seasonal and always changing, new products coming out all the time because there's always new motorcycles coming out. So we couldn't just take our off season and build extra inventory. We found we really just needed to ramp up our operator labor and react to what customers were ordering. And what we found was that our labor costs in the busiest time of year went through the roof. Our quality went down, and our costs went way up because we couldn't assimilate enough operators to do that effectively enough. And then we needed to lay them off in our off season because we couldn't carry that much cost. And so that's why we looked at automation to solve some of those problems. And it was enormously successful. Quality went way up. Employee satisfaction went way up. We weren't doing any more seasonal hires. And another thing for us, a big cost for us back then was machine crashes. Machine crashes were almost completely eliminated because we took so many of the human factors out of the system. All those things were stored in the robot configuration, and all the end user had to do is call up the correct part that they wanted to run, enter a quantity, make sure the right CNC tool set was in place, and then run. So it was really transforming for us.
You brought up such an important point because you brought up the breakdowns decreased. And one of the things for me in my field of automation is people look and say, yeah, but your robot runs slower, or it doesn't look like it goes as fast, but it's controlled and it just keeps on giving output. Is that one of the reasons that a lot of your guys' equipment would get damaged because somebody runs the RPM higher than they should? Like, explain in your industry why automating it causes less machine failure.
Well, I would say not as much pushing the machine hard. Prior to automation, we went through a lean transformation of how we did our manufacturing, because we were failing consistently, because we were taking the ideas, old school ideas about, got to make the machine as efficient as possible because the machine is the most expensive thing in the shop. And what lean really taught me for our facility was the machine is not the most expensive thing in the shop. Not being able to produce parts when I need them is the most expensive thing in the shop. So that brought in standardization of fixturing, things like that, where we were trying to make it easier to change over between parts and create fewer opportunities for errors, even back then. Now there were still a lot of errors, and automation just reduced the number of errors because more of the things that could create errors were being stored in a configuration instead of being required to be remembered by the end user. Things like, oh, he loaded a part, he forgot to tighten down the fixture. Whoops, we just, that's the sixth time that's happened, and this time the spindle's making noise. Yep, we got to replace the spindle. Or, I can't tell you how many tool setters were replaced because someone flung a part out and I hit the tool setter or something like that. So it tended to be more, we with automation, you get more controlled processes that remove a lot of the human interaction where where a human will forget sometimes and make a mistake.
Mm-hmm.
But you're right. One of the things, especially with high mix manufacturing, and something that we face time and time again, is why is that robot going so slow? Why can't it do this faster? Well, I want the robot to load 30 parts in the machine and then go, so I get more productivity. And we do spend a fair amount of time kind of reinforcing in people that a lot of times in high mix CNC automation, to really get the most benefit out of the automation, you are going to give up some of your maximum productivity. It has mostly to do with either running multiple parts at a time. There's certainly cases where that's a good idea to do, but a lot of times people are trying to shove that down the automation process's throat, so to speak, and it just doesn't work well. Or they'll have to make some compromises in how they machine the part to fit more standard work holding that is faster to change over. Or they'll look at they'll compare the cycle time of the CNC machine with an operator loading. They won't consider the operator loading time at all. And then they'll compare that to the robot plus the CNC machine. And they'll go, hey, this is the step backwards. And what I can say is 99% of the time, I can make parts for substantially more money with more total productivity with our slow automation than any operator setup. And many times, again, if it's a high mix environment, than any fast robot, because you're not spending, a day between setups to go from making one part to the other. With our equipment, it's typically 10 minutes.
So, to make you feel better, this is the same thing I experience in my line of automation. I'm automating lawn mowing and golf ball picking and washing. And you said something that is the same thing that happens for me is they'll look at the cost of one of my pieces of equipment. So let's say one of my robots is 30 grand, right? And then they'll look at it and say, well, I can buy that zero turn for $16,000 and just put a guy or a girl on it. It's like, yes, but my robot never calls in sick. My robot is here. If you want to run it, 18, I have charge cycles to figure, so you wouldn't have to do that. But 18 hours continuously, I can do that. I don't need light, I don't need anything. And so you brought up a point. They don't, like in your world, all they should be concerned about is the cost per piece, and then figure out why they want it, why they want to ram it down, as you said, the automation throat in the first place. Where if they make it choke, their output actually decreases. Let it do its thing, and then if the cost per piece is cheaper and they want more output, why would they not just buy another piece?
Yeah. Yep. Exactly. One of the challenges in convincing people to move to automation and CNC manufacturing is old-fashioned or misguided assumptions about costs. Oftentimes, when manufacturers make, especially less sophisticated manufacturers, make decisions about investing or how they utilize their equipment, they look at $100,000 CNC and think, okay, that's worth at least 3 times per hour as much as my operator loading it. That CNC has a useful life minimum of 20 years, right? And probably costs $5,000 a year in maintenance, various things, and it should be available for production for $20 an hour. And if you do all the math, it's in the range of, but that CNC amateurized cost is somewhere between 50 cents and maybe $2 an hour. And yet, most manufacturing facilities historically have put more emphasis on optimizing that machine than optimizing the people that operate it. And that's extremely misguided. And especially when you look at, you bring in inflation and inflation of wages. Once you've bought that piece of equipment, it's a sunk cost. Use it. That operator, their wages are marching up like this. And then, some accountant will come in and say, well, wait, you're not putting in the value of the money that you put in that you could be in a savings account or, invested in this or that. I'm like, yeah, all those things, the operator labor cost is still way above that. So the changing how people look at their manufacturing costs and really understanding where those costs are and where their constraints are really changes the equation on the value of automation. And again, I'm going to say the vast majority of the time, automation is going to crush operator labor day in and day out. And I would say, I'd go so far to say that in the CNC manufacturing industry, if you're not working towards automation, you are not going to be competitive in the future. And it could mean the difference between having a successful business in the future and not having a successful business in the future. The cost difference is that much. For Recluse, it easily reduced our total cost of manufacturing of all the controllable costs by 1/2 total. That's a very big number. Now, that's not going to be the same for all industries, especially if you have very high material costs. For example, like if you're doing titanium, just the material is just a very big portion of your total cost. But if you're working with lower cost materials and you're working with in a high mix and you're working with lower cycle times, then a large percentage of your total cost is not the machines, it's not the rent, it's not the material, it's not the tooling, it's none of those things. It's the operator labor. And reducing that is going to increase your bottom line significantly and make you more competitive in the world market.
So let me ask you a question. When you started doing this and you decided, yep, Recluse, we need to automate, how did you acquire the capital or the funds to do it? Right. And hopefully you don't mind me asking that question, but this is one of the things I found is, especially when you started in 2016 or whatever, not only do people not understand it, but sometimes the banks didn't understand it. They would take the cost of a piece of equipment and then instantly in their calculator assume then you have to add a fully burdened labor rate to the equipment. With automation, you don't. So how did you overcome that challenge, or was it even a challenge for you to have to overcome?
It really wasn't a challenge, to be honest with you. And I think automation equipment is still, don't tell this to any bank, but it's probably easier to finance in general than it should be. And I'll say that for a couple of reasons. Now, another reason that we moved towards collaborative robots is because they are generally going to have a higher resale value than industrial robots. They have a lower deployment costs. They can be more easily dismantled and repurposed into something else. And so most, and where I'm getting at with those kind of statements is that if something goes wrong and the bank needs to take the equipment back, they're more likely to get a higher residual value for that equipment than they would otherwise. Bank doesn't care as long as you make all the payments. It's when they have to take it back that they care, right? And so, but in 2012 and still I'd say in 2024, banks really mostly look at automation equipment just like any other piece of equipment. It is almost all this stuff is sold on what are called leases, but they're really just a fancy way of doing a loan, and you pay a little bit less than the lease by having a guaranteed, no, you got to make all the payments. The bank knows they're going to get all the interest. So I would say that financing is really more about the person buying it and their credit reputation and all those types of things than it is about the type of equipment that they're buying it. And a bank will look at a robot system generally just like they would a saw or a CNC machine or anything else like that.
So in your case, though, when you had to develop it on your own and you were basically putting parts and pieces
Yes.
together, how did you handle that?
Well, fortunately, we were a big enough business at the time. We had grown into a big enough business that we had enough excess cash flow to do it. It helped that the robotics company I was working with at the time, they were brand new and they were hungry to do something. And so they did it, way cheaper than they would have otherwise. And then I think the other thing that helped is, it turns out there's to make a good high mix automation system. I would say having the right software behind it is another piece of that equation. And I'm a software guy, so I did a lot of the software myself early on. So that combination of things made it relatively inexpensive. And once we kind of had the first two done, then I was able to borrow money from the bank to buy my own systems. So that made it easier. And even those first two systems, now the first two systems, I'm pretty sure we paid cash for. We bought all the parts. We were paying the robot guys some money. And so we self-finance that internally.
Yeah. But yeah, we have very similar parallel there because my automation company, believe it or not, my landscape and snow removal company was the EC to the new automation startup. So sounds like it was basically the same type of scenario until you kind of got rolling. It was the same thing for me. Now that we are rolling, I can get bank funding because I've proven that I have a profitable P&L. You brought up how they do the leases because they're basically just dollar buyout leases. So yeah, the bank is saying as long as you pay for it, we have no desire to repo this thing because if we do, what are we going to do with it? So what are some real world, obviously you started it first for your own company, but now maybe if you could explain some of the other people using it in the industry, some problems or some parts you're making.
Yeah. So that's a great question. And we have customers, all across the spectrum, from aerospace to firearms to power sports to medical to industrial, just about everywhere. And I would say that the sweet spot for our customers, again, is high mix. You know, we have technology between our, and it's not just, there's the two most common types of automation or types of machines that are automated in the CNC industry are lathes and mills. We have great technology in our lathes, and a lot of that technology is software, but all the things that we do there are pretty common types of equipment. We use a double-headed gripper that's widely used in other automation systems. Really, in our lathe automation product, it's really about our software that makes it so easy for a machinist to add their own parts to the system and then to switch between making parts very quickly. And that high mix thing is so important. On the milling side, we have some work holding technology, and that is what really makes that part of our technology, along with the software, work so well in high mix. So our customers are high mix customers where that they really recognize the value that they need to not just add one part to the system. They got to run many, many, many different parts. And it's going to tend to be companies. And I'll add one more kind of thing about our equipment and how it relates to our typical customer. And that's kind of size. What we are automating primarily is parts that maybe are as small as a 1/4 inch by a 1/4 inch by a 1/4 inch cube, let's say, to the largest parts we really automate are about 10 inches by 10 inches by 10 inches of a cube. So if you look at customers out there that are making parts in those kind of range, have a lot of parts in that kind of range, they make a lot of different versions of those kind of parts. That's our sweet spot. And it tends to be medical, power sports, firearms, industrial valves, things like that. And then the other thing I would say is we do sell our equipment to quite a few contract manufacturers. Contract manufacturers make parts for other people. And again, that's a market that automation typically hasn't been able to touch because there's too much variation, and your cost to introduce a part have to be very low, and your changeover times have to be very low. But that's a market that we can also address.
So do you just sell your product like they have a spec, they have a scope, you build a machine, or you sell the machine, or do you do it as like a robotics as a service where you service the product if there's an issue? You fix it if it needs a software rewrite, like change, you do it. How does that work?
Yeah. So again, I'd say we're pretty different there in this regard than most of the other companies providing automation out there, or what a lot of the robot makers are selling. So traditionally, industrial robots have gone through regional custom system integration. A manufacturer says, "Hey, I've got this part. I need to run 10,000 per month. Design an automation system for me." And they'll be gone for 3 months, and they'll come back with the proposal for, $750,000 or something, depending on how complex of a system it is. And then from there, it'll take 9 to 12 months to deploy. We don't do that. On the other end of the spectrum, you have collaborative robots that have come out, and what's been the push there from those manufacturers, at least where they started, is, hey, we got a super easy robot to program and deploy. We can teach you how to do it. It's safe. And then we have a catalog of accessories, and you just choose the accessories, and it's so easy that you'll do it all yourself. And we do support those customers. We sell those customers parts and pieces, but what we do really is sell an automation as a product. So we do some bits of customization. We want to take care of people. And we want to make sure that we support the parts that they need to make. And our core work holding products are good. They're like an 80% fit if you look at kind of the parts that we're trying to make for customers. Sometimes there's some things that customers need to do that are important to them that we need to bring in third-party accessories, and we do a little customization. But by and large, we sell automation as a product. We have in stock automation systems. If someone calls up and says, "Yeah, I need to load a lathe, and I got these 6 different parts. I want to work with initially, and they ask for a proposal, we'll show them our standard product and say, yeah, it ships from stock. It can handle all those parts. We can help you integrate those parts for you, or you can do that. We'll train you to do them yourselves. We can install it for that system for you, or you can install it yourself. We put a lot of focus on making our equipment very, very easy to install and maintain so that that customer is enabled to take care of their own stuff and they don't become reliant on us, because we are in Boise, Idaho. Boise, Idaho is not a big enough market as a regional system integrator to support a company like ours. We got to sell nationally and internationally. And what that means is we have to sell a product that can scale, and that can, by and large, be supported by the end user. So about 35% of the systems we sold last year were installed successfully by the end user. We installed about 65% of them. But another important part of our systems is what we call remote support. We're also a software company. And if the customer has a problem, we can log into that system remotely, diagnose what went wrong, have the customer take some pictures, explain the problem, and 99+% of the time we can solve customers' problems remotely without any kind of site visit. So we like to, as much as possible, think of automation, CNC automation, not as something that's custom or built to a specific customer specification, but a very versatile product that customer can make perform the way they need it to perform for their machine.
So as I listen, so I'm a guy that I'm importing ball wash systems right now for golf from the UK. There's a big round scrubber that scrubs. I've got a drop pit, stainless steel drop pit. And, maybe your equipment couldn't automate it, but maybe it could, right? Like if there's somebody like me that's listening to this podcast, like, man, I'm importing something from someplace that maybe I should just make in the United States, save the money on the shipping. Is a system like yours, is there a possibility there? Or how does one go about figuring that out?
So I'd say a couple of things. First of all, we are pretty narrowly focused on CNC manufacturing, or machine tending, I'd say, is the more general thing. We have loaded and unloaded things in and out of other things besides a traditional CNC turning machine or CNC milling machine. But we don't do polishing. We don't do welding. We don't do, a lot of these other things. So if you were looking to manufacture one of those things, and that device you're talking about has components in it that are CNC machined, and you don't know anything about CNC machining, well, the first thing I'm probably going to tell you is, unless you know you're going to sell, 500 of these things a month, and you can justify having your own internal manufacturing, we'll help you find a contract manufacturer. We do some limited contract manufacturing. We may even offer to quote that part for you, and we would develop all the fixturing and all that stuff with our standard systems and start making it here for a price. And when you were ready, if you were doing enough volume, you can buy the whole manufacturing process from us. Show you, yeah, you want to buy this CNC machine from your local supplier. Here's all the automation equipment. There you go. We've done that before with customers. But if it has to do with CNC manufacturing and automation, give us a call. We might not be the right fit for you, but what we probably can do, if we're not the right fit for you, is tell you where you need to go to get what you need. If you have a machine, you talked about a golf ball cleaning machine. That is a machine that takes a part, you put it in the machine, and then out comes the part completed, right? That is technically what's called CNC machine tending. So that is in the line of business of what we do. I'd want to really look at your application. There's every machine tending application has what's called an in feed and an out feed. We'd want to look at the in feed, We'd want to look at the machine and how the parts have to be placed in the machine. And then we'd want to look at how those parts have to come out of the machine. And we may have a good fit for you with our standard equipment. We may not have a good fit for you with our standard equipment, but we may look at that and say, hey, we could take these pieces of our standard equipment, add this piece and this piece, and make a great solution for you. Or we may look at the whole thing and say, you know what? You really need to talk to a regional custom system integrator that can customize the right solution for you, because your problem can't really be met by a standard solution. So that's how I'd answer that question.
Well, and so listen, I tell people all the time, this is why I do this show, right? Because at the end of the day, there's a community of people that we all think similarly, but we kind of have our I don't want to call it niche spaces, but and it's a lot of our spaces are really kind of niche in what we do, but there's so much opportunity to collaborate outside of our space here. Someone knows this person that can help, and it just moves the industry forward. So it's very exciting for me to hear someone like you talk about what you're doing and why you did it at your company, because now that I became an importer and I'm bringing in these systems, and, to explain what my system does is, we collect golf balls on a golf course, and we drop them in a bin, and that's the stainless steel hopper I need to make. Then we put them under vacuum. We move them 100 yards into a centrifugal scrubber, and I can change the scrubber with frequency drive, in the motor, how many times I let it go through the round scrubber. And then out of the scrubber that's still under vacuum into a collector. From the collector, we drop into a final bin, whether it's a vending machine or just a bin that people scoop the balls out, put them back out. And what's always crazy about automation is you needed to make something to make clutches and round components, right? And most people, they would go on Summit or Jegs or whatever place they buy clutches on, and they just order a clutch. They don't even think about it. For me, somebody hits a golf ball, they don't think about how it needs to get washed and collected and brought back. So yeah, it's always interesting to talk, because this is why people listen to the show. We're talking about things that people they take for granted, right? They take the fact that these parts are going to get made. And I hear people talk all the time about, well, let's manufacture in the US. We have to bring all the manufacturing back to this country. But no one wants to solve what it costs to live in this country and the labor that it would cost. And then once you actually give someone a bill, they're like, well, that's too expensive, right? So there's a lot of things we can accomplish here by automating manufacturing in this country, because now we keep the money here and it's not spent in shipping, and we make the raw goods here. So as you can tell, I'm very passionate about it. It's why I do this show.
Yeah, 100%, 100% there. One of the things when we talk to larger companies, we deal a lot with small to medium-sized enterprises, but we do have some bigger customers as well. And a lot of those companies, we are automating their problem parts that they really couldn't get made overseas effectively. And I talked to them about their overall manufacturing operations and strategy, and why they move parts overseas. And it's this belief that the parts can be made so much cheaper overseas. And I challenge them about their assumptions on cost. Again, when they see a number on a quote from a vendor, that looks great, right? And when they compare that to what they're making internally with their labor and how their accountants calculate all those costs, well, a lot of those costs that are calculated by the accountants assume things like a 7% amortization on the CNC equipment that actually lasts 20 years, right? Things like that. They include the cost of the building that they didn't get rid of. They still have the building, right? Maybe now it's, instead of having machines that make parts when they're needed, it's now storing excess inventory that's coming from, overseas, right?
Yes, I was
And
just
they're not
I was
including that, right? They're not
Yep.
including the shipping costs. They're not including the quality problems. They're not including a pandemic that, interrupts that supply chain. They're not including the cost of not being able to produce as competitive products because all their manufacturing is over there and their time to prototype materials goes up. Or when they release a new product because they rushed it, because they couldn't prototype quick enough, there's all these other costs. And then I talk to them about where their costs really are and what the difference is in cost between overseas and here. The people overseas, they're paying about the same for material. They're paying the same for the equipment. They're typically paying very similar energy costs. It's the labor that's the biggest difference. And if you take out in our industry, we can typically take out between 70% and 90% of the labor. When you take out that much labor, you will almost certainly make that part for less money in the US, and you'll bring all these other benefits to your business that you're not measuring. So automation, from my point of view, is key to turning this transformation that our manufacturing industry took starting in the 90s, where as soon as a purchasing agent saw that they could buy a $10 part for 10 cents less in Asia, they decided to start purchasing it from Asia without really taking the full cost consideration into place.
Yeah, no, I mean, some of the things you're bringing up are so powerful because even you said at your own company, you were able to hire less seasonal workers and it was better for your quality and then your full-time people. The reality is in our economy, full-time workers are much more likely to refuel the economy and spend money in a community and live there full time because they have full-time work. Seasonal employees are scared to spend money, right? So it doesn't fuel local economy. There's so many things that people don't take into account in the economics of manufacturing here in this country with automation, because what I'm finding in my space, in totally different spaces, but there's parallels for sure, is people that are maintaining my automation and able to pay more money to keep it working. So they actually have a better career. They're more likely to stay with me long term versus, as an employee hopping for a 10%, 10-cent raise because they're going to go to somebody that's going to pay more, or a temp agency, probably in your world, that'll pay a little bit more money, whatever, right? But then also you brought up earlier, there's the cost for the part, but if you don't have the part to sell when you need it, you've lost a lot more money and opportunity than you
Yes.
would have gained by just saving 10 cents, you know?
Yes, absolutely. Absolutely.
Yeah. So, just to unravel some of the stuff that you were speaking on when you were talking, like that's how I was hearing it. And that's what makes me, like I said, so excited about the future for all of us with automation, because so many people are so like against it, like, oh my God, it's going to take a job, but it's not. Half of these jobs are not fillable. There's not people that actually want them, and there's definitely people that don't want to just work part-time as people need them. But if we can get people that are like automation advocates in these spaces, it'll make sure the machines can automatically run, tool them, do all the things like you said that need to get done. It'll be a happier workforce.
Oh, 100%. Absolutely. Uh, when we first started automating, the big concern with all the operators was, I'm going to lose my job. I'm going to lose my job. I'm going to lose my job. And initially, whenever anything went wrong with the robot, it was like, oh, see that thing, that'll never work. That'll never work. But then some of the people started realizing, well, wait a second, this thing's making my job easier. This thing is making it easier for me to exceed expectations, exceed my objectives. We never fired a single person, or laid off a single person for automation. We didn't need to hire people back sometimes when someone left. We didn't need to hire more people as the company grew. That automation was a buffer for us. And ultimately, I still have guys downstairs. I sold Recluse about 5 years ago, 6 years ago, but I still have some of the original guys that were down there when we first brought in automation. And every one of them will tell you that the robots made their job 100% better. So automation can be a real plus, not just for the economy, but also for the people in the workforce.
Yeah, absolutely. So I think we've kind of hit the point in the show where I think we've used our platform to talk about the automation side. So tell me a little bit about you. You said you sold Recluse. How did that feel? Like, was that hard for you to do? Because I can tell
Oh,
you as an
yeah.
entrepreneur myself, that must have been like, it's like maybe like walking your daughter down the aisle in a wedding
Oh,
or something, So
yeah. I would say it's something like that. I don't know if that analogy is the best one, but it's certainly giving up something that was a big part of my life, even my kids' life. But when I had someone approach me about selling it, and my initial reaction was, "Nah, I'm not really that interested." And then I had a pulmonary embolism that put me in the hospital for a few days, and I kind of was shrugging it off. I didn't really understand what a pulmonary embolism was, and then the doctor said, X% of pulmonary embolisms present as sudden death. Consider yourself lucky. And so that was kind of the inflection point for me to say, uh, I've done really well with it. I have 98% of my wealth tied up in Recluse and VersaBuilt. I need to take some chips off the table, have some more fun, do some of the things that I want to do. So that was something I did. And I wanted to put some more focus in VersaBuilt as well. That was the other incentive. So, but I've always been really, uh, passionate about engineering. I was a software engineer in college, but I really loved mechanical engineering. So Recluse allowed me to teach myself about mechanical engineering, and robotics helps me bring those two things together. I'm really super passionate about power sports. I I love beer, but gasoline is my favorite liquid. Um, and sadly, I burn more than my fair share. I really enjoy off-road motorcycling. I enjoy uh, track motorcycling, road motorcycles on a racetrack. I don't do too much street riding anymore. I'm a pilot. I enjoy flying. I also enjoy cars on the track, and I enjoy traveling and spending time with my kids and the rest of my family.
So how many kids do you have?
So I have three of my own kids, and then I have a stepson as well. My oldest son is 28. He's a software engineer. My middle son is 20. He's a mechanical engineer, and he's worked with me at VersaBuilt from the beginning. Excuse me. My daughter's 23. She studied textiles in college and has been doing some marketing, some for me, and now doing some other marketing for other companies. And then my stepson is 22, and he's an on again, off again college student in Salt Lake City. Great kid as well.
Awesome. So was your daughter an inspiration for you to be on this podcast, or do you do podcasts often? Sounds like something she might have encouraged you to do if she's doing some marketing for you.
Yes, and she's encouraged us to just do a lot more. She got me into doing blogs. I've done a lot more blogging since she started doing some work for us, and just more general outreach like this. Talking to the people, which I think is a really great thing to do.
Yeah, my daughter is my COO at AOS, so I'm like
Nice.
you. I'm fortunate to have, and then my stepson is one of my main robotics guys in Florida in that market. I have another stepson that I'm looking to put into a market because just like you, we're doing this nationally. So So yeah, we have so many parallels. Yeah, I'm a car guy, definitely not a two-wheel guy. Uh, I I like speed too much, so my issue always was I just feel more likely to survive a mishap on four wheels than two wheels, you know. So I've always kept myself up, but
Amen.
you know.
Yeah.
So car wise, you said you're into cars. What you got a favorite car or vehicle you got in the garage right now, or what?
Oh, I just recently traded a 2013 Porsche Boxster for a new 2024 Porsche Boxster. But with 10 inches of snow on the ground here in Boise right now, that was a poor life choice. And now I'm driving my cabin car, which is a 1994 Geo Tracker around town.
Holy cow!
Um,
How do you go from a Porsche to a Geo Tracker? That is. I
Let
mean,
me
you want to talk about that's insanity. I mean, that's a hard one. That's interesting. So, because you look like a pretty
it's
tall guy from the video right now. I don't know how the hell you're getting a Geo Tracker.
yeah, I'm almost 6'4". So no, I think just fine in the Geo Tracker. So, but yeah, and then I have a Corvette Grand Sport that is a dedicated track car that I take to
What
the
what year?
racetrack. It's
What?
a 2018.
Okay, so I had a Z06, 2015. It was Shark Ray. I actually
Okay.
traded it in, thinking I was going to get Z06. The dealership told me they were going to get allocation, and they still haven't gotten allocation. So I let go of my Z06, and I'm sitting here Corvetteless now, which is turning out to be harder than I thought it was going to be. But I don't drive a Geo Tracker. My other vehicle is a
Yeah.
TRX Ram. So I really can't complain too much. 702 horsepower, but
Yeah.
so yeah. So yeah, you really go from one variable and just on the Porsche thing. My daughter's dream car, it used to be a GT3 RS, and now it's a GT2. But our motivation together is to grow the company large enough. And she says she's going to buy me a GT3 RS so we can drive our Porsches together. So I think I've got a pretty good daughter to want to do that.
Yeah. Oh yeah. Yeah.
So how about so I mean you kind of cover what you do for fun. So how about you've got a stepson, so of course it sounds like you're remarried. How about your new wife or what does she do?
Yeah. My wife has her own business. She sells medical insurance to small to medium sized businesses here. She's a hell of a salesperson. She's doing really great, really growing her business right now. She's very passionate about it.
Awesome.
And we enjoy skiing together and traveling together. Uh, so yeah, life is really good.
Awesome. All right. Well, with that, I think we got to learn a little bit about you, about your family. I think it's great that you get to do that with them. And I want to thank you for being on the show. It was a really good time. I learned a lot about your company, and I wish you great success, and hopefully you can keep doing what you're so passionate about.
Yeah, well, thank you, and the best to you and your family as well.